It's kind of the stuff we've been doing from E1 through E3, and then E4, just the graphing part, puts it all together. Anybody want to start by asking maybe a specific section of this to work on that you've been troubled with? Maybe like intercepts or maybe the vertical asymptotes or holes. What's something that's troubled you?
Can we go over the intercept thing?
Sure. Let's take a look at intercepts. So let's say we have a function that says r of x equals 2x squared plus 4x minus 7 over 3x plus 6. Let's say I want to find the y-intercept first. How do I always find a y-intercept? Set x to 0. Remember, this is what the y-intercept is. 0 plus 0 minus 7 over 0 plus 6. So really we could look at the ratio of the constants, as always. So it becomes 0 comma negative 7/6. You can write that as a decimal if you'd like. It's probably around negative 1.15 or 1.14, I forget where that is, but a sixth is something like that. When will you not have a y-intercept? When will you not have a y-intercept? When the whole denominator becomes a 0. So if this had been 3x squared, and this had been a 6x, these would both be 0, right? So as a result, you get negative 7 over 0, which is undefined. It does not exist. Why do we not have a y-intercept when that happens? Why not? Besides mathematically, physically on the graph. There's a vertical asymptote there. So say I did this. You don't have to draw it or write it, but say I did that. What could I take out of the denominator? What value? You could take out what?
Oh, 3x.
You could take out a 3x, yeah. So in this case, you could think of this as 3x times the quantity x plus 2. So as a result, where do vertical asymptotes come from? Remember, they come from the denominator. So the vertical asymptotes of this problem would be x equals negative 2 and x equals 0. Remember, whenever you factor an x out, x equals 0 is either your vertical asymptote is in the bottom, or 0 is your root if you're in the top. So the vertical asymptote would exist at x equals 0, which is the y-axis. So this kind of a graph would already have a vertical asymptote here. So you cannot, okay, the blue dashed line I'm putting here, you cannot have a y-intercept if you have a vertical asymptote. It's impossible. Remember, vertical asymptotes themselves are discontinuities. You could have a horizontal asymptote on the x-axis and technically still have an x-intercept. Okay? That's the different one. Remember, we talked about that. Horizontal and slant deal with end behavior, not discontinuities. So you could have a point crossing a vertical or a slant, a horizontal or a slant asymptote. You cannot have a curve, though, crossing a vertical asymptote. Anyway, let's go back to the problem. The problem, though, was not this. It was this. So we wouldn't have any of this stuff. Now, what would the x-intercepts be here? How do you find the x-intercepts? You don't have to tell me what they are, but how do you find them? How do you find x-intercepts? Set y equal to 0, okay. So I set this original function up here equal to 0. What's the only way a fraction could equal 0? If the numerator is 0. Some of you still keep making this 0 here in the homeworks. Okay, only if this is 0. Now, if this is 0, what do I want to do to determine the zeros of that?
Factor it
I want to factor it out. Can this be factored? AC method. What's AC?
14.
Negative 14. Are there any things that multiply to negative 14 that add up to 4? Anything you can think of? There's nothing I can think of, so I wonder if you can. Nothing, right? So what do you know? You have to use what? Quadratic formula. Okay? So here, remember, ignore the denominator to find the roots, or to find the x-intercepts. Ignore the denominator. set this equal to 0. Well, if you can't factor something, you go to the quadratic formula. So go ahead and run it through your program. Tell me if they're, and you can see by looking at this, if they're real or imaginary, but tell me what the roots are. Go ahead and type in your calculator, please. Again, run through your program. 2, 4, negative 7. Mike, tell me what you got. Give me 2 decimals.
1.12.
And?
-3.12.
So clearly we can see the symmetry in this graph, right? They both have 0.12s, which tells me that it's probably, remember how the quadratic formula is really negative b plus or minus? The plus or minus has to do with like a 1.12 or 2.12 or something. And that's probably because the square root of b squared minus 4ac is something 0.12. Did others get this as their answers? Luca? Yeah? If you didn't get this, it means you have a mistake in your program, or you didn't enter 2, 4, and negative 7. Maybe you entered 2, 4, and you hit the minus sign and hit 7, or maybe you used positive 7. Okay? So check what you did. Now, just because you can't factor, don't assume there's no x-intercepts. And that's why I specifically chose random numbers for my numerator. I purposely didn't make this a problem that you could factor, so you can see that you still get x-intercepts. How do I write those as coordinates, obviously? As coordinates, they are? Okay, so there's my coordinates. So I've got my y-intercept up here, and my x-intercepts down here. Now, take a look at this example. You think I would probably give you one of these to graph for the test? It's possible, but you'd have to use long division. What would you get for your slant asymptote if you did long division here? If you do long division, what would you get for a slant asymptote? Now, the reason this is difficult, and that's why I said would I probably give you something like this, what would you use in this problem here? What would you put up top for this part? Luca. Yeah, 2/3 x, because 2/3 of 3 is really 2, and x times x is x squared. So when I multiply this by this, and this by this here, the 2/3 x times 3x gives me 2x squared, which is exactly what we always want to get. Then 2/3 x times 6, that's not that difficult because 2/3 of 6 is 4. So in this case, we're going to end up with, 4x. That's odd. I didn't purposely do that. All right, let's see what happens. So we have a minus here. We're going to get 0. We're going to get 0 minus 7. So then we have to say to ourselves, well, what's going to go next? What goes next? Anybody? But what would you put up top then, really? You need to put something there. I know it's weird. You need a placeholder. What do you need? Plus 0. And I'll explain this for a sec, all right? Because you're not done with the problem. -7 is not the only -7, when you bring it down, it's not going to be a y-intercept. So when we multiply this to 0 through, we're going to end up with here 0 and 0, which will give us this. But it's minus here. We're going to get negative. Oh, we're still going to get -7. But keeping in mind that this is not going to have a y-intercept for the slant asymptote. So where will the slant asymptote pass through? What? The origin. The slant asymptote will pass through the origin. So the slant asymptote is y equals 2/3 x. There is a remainder of -7, but make sure you don't confuse that and put the -7 up as the y-intercept. So that's the reason I'm thinking about the 0 there. Put the 0 up top to remind yourself that this indeed is the slant asymptote. You don't need the -7 included here. So this would pass through the origin in this case with a slope of 2/3. So, I mean, this problem would be a little bit trickier than what you've seen, but you should be able to do synthetic or long division. Just practice them with these. What else? What would the vertical asymptote be in this problem? Remembering that the function is, what is it? How come? Correct. Remember setting the denominator equal to 0 here in this case. What was it, r of x, I said? Okay, so the vertical asymptote would come about from factoring out a 3 in the denominator. So write the denominator instead of this as 3 times the quantity x plus 2. So clearly negative 2 is your vertical asymptote. So you've got a vertical asymptote at negative 2. You've got a slope of 2/3 for this slant asymptote, which is a little bit less than 1. It's a little less than 45 degrees. Again, I'm just sketching. So we can already see now that this graph is broken into quadrants. Okay? Broken into quadrants based on my asymptotes, not my axis. So here's 1, 2, 3, and 4. Just turn your head to see. Now, what you'll notice is that with these, you see a lot of, what's the word again? Symmetry. Okay? So maybe we'll see symmetry here, and here, or maybe here, and here. Look. You good? Okay, so this is, again, remember this is the slant asymptote. And this is the vertical asymptote. What was our y-intercept? -7, what? Over 6? -7.6. So around -1.1, somewhere around there. So we're down here. What was our x-intercept? Or x-intercepts? 1.12, so we're talking about over here. And -3, which is back over here. Because the vertical asymptote was -2. So what do you know already? Where's this graph going to look? What is it going to look like? Somebody show me with their hands. Just draw it in front of you. Yeah, you're going to see this? I saw that. That's right here. For sure. And then what about down here? What do you see? What is it going to look like? Yeah, like that. Okay, so you know based on where these points are, what it's going to look like. The rational functions are all similar in looks. If you have two vertical asymptotes, usually you get like this kind of graph up here with a piece in the middle. Or if you have two vertical asymptotes, you might get two down here with a piece in the middle. But if you notice this with your homework problems, that they're very similar looking. When there's one vertical asymptote and a slant, you traditionally get something like this. If there's a vertical and horizontal, you might get something like this. Okay? But you see the symmetry that's involved. So what kind of points would I choose? There's no holes in this graph. What kind of points would I choose? For my table next. Now, give me some points for x. Why would I want to choose certain values and pick them specifically? -4 works, yes. This is around -3, right? So we need a coordinate out here and out here, maybe one in here also. So -4, okay, what else? Go a little bit, there's -4 here, right? Go a little bit further so you can get more information. What's after that? Yeah, I'd go to -5. In by the asymptote, go by halves. So this is around -3, so what would you choose? -2.5. Okay, I think those are sufficient for the left side. How about the right side? The right side, what do you have? Kel? 2? So we know that this is 1 right here. So 2 will give us another point. Good, that's enough on this side. What about over here now? Kel? What about over here? This is 0 for x. What would this be? -1 and -0.5 in that region? Okay. -0.5. Let's try -1.5. Okay, just so we get close to the asymptote. Remember, the asymptote is at -2. So we want to get close to the asymptote always. Always, always, always. So you can see the unbounded behavior. You can see how it rises up greatly. So give me values, please. Go to your calculator. Let's go practice. A lot of you guys need to practice stuff. The numerator needs a full parentheses around it. The 3x plus 6 needs a full parentheses around it. Plug it into your x and y table. Here. What do we have? Give me some values. So let's plug in. Give me just run straight down. Run straight down your line. Luca?
Negative 4 is negative 1.5.
Just give me the y values. Go ahead.
I get the point right there. So it's negative 2.5556.
So negative 2.6 then. Okay. 2 is 0.75? Okay. Aren't you just typing? Oh, you're on your iPad. That's fine. Come on, just type them in quick. What do you got? The ones that are missing.
2.5 is 3.
Negative 2.5
Yeah,
is 3.
that's what I got.
Negative 0.5?
Negative 1.889.
Mike?
Negative 1.8.
For negative 0.5?
Oh, it's easy.
That's fine. Negative 1.5, Mike? What do you got for that one?
Negative 5.667.
Okay. So let's graph these, let's plot these points. Negative 4, negative 1.5. So here's negative 3, negative 4, negative 1.5. Negative 5, negative 2.6. Negative 2.5, comma 3. So we can see the curvature of the upper part of this graph. There's that part of the graph. On the other side, we'll plot 2, 0.75. Negative 0.5, negative 1.9. Negative 1.5, negative 5.7. So again, we see the curvature of this part of the graph. Remembering that it's not going to cross the vertical asymptote, so be careful when drawing your lines. Okay? Does that make sense, the way it looks? You need to practice this stuff, guys. I walked out of the room for a minute and you weren't done. You gotta be quicker. It should take you literally 20 seconds to maybe plug it in and another 10 seconds typing these numbers. So you need to be fast. Like the slow motion kind of thing on your test is why a lot of you run out of time. I don't know whether it's just a matter of practicing more with your calculator at home or just step up to the plate a little bit here, but you need to do work a little bit quicker. Okay? It's evident on your test, and it's not just 1 or 2. But there's like 4 or 5 of you that do fine, but there's a few people that always fall behind. You got to be quick. You can't sit there and say, all right, now how do I type this in? It needs to be second nature. And I've gone over this so many times with you. There's a difference between running out of time and not understanding something well enough to go quickly through it. If you understood something really well, I should have come back in the room. Everyone should have had the table done. Everyone should have had points. And especially what's annoying me is that people still don't have calculators in this class. So bring a calculator in, please, okay? I'm trying not to get upset right now, obviously. It should be second nature to have your calculator and be ready to go. All right, let's try another problem. Let's take a look at one that's a lower degree on top than the bottom. So let's say we have h of x equals x squared plus 4x over, actually we'll do same degree for this one, x squared minus, let's see, I'm trying to make it go on a whole. Say 5x minus 6. Make it a little bit easier, actually. How would you approach this one? Give me your first step. First step, quick. Yes, Luca.
First, looking at the horizontal asymptote at 1.
Good. So you could start with saying there is definitely a horizontal asymptote at 1. Next, somebody else. Actually, first, Luca, why is that? Just so we all are clear.
The same degree as obviously just 1x squared over 1.
Yeah, you look at the ratio of the leading coefficients, which is 1 over 1. That's the blue ones there. So it's y equals 1. It's mean. Agreed. So let's check for factoring, for holes, vertical asymptotes, zeros, everything comes from factoring. So what do you got? Factor for me. Mike?
Wait.
Yeah, question?
Well, I'll factor first, I guess.
All right.
So I guess the GCF in the first one is x, and then x plus 4 parentheses. And then the bottom is negative. Wait, oh, it's negative 6. And plus 1.
Okay, Mike, and your question?
My question was, since the degree of the exponents is equal, what is that?
We look at the ratio of the leading coefficients. And see how this is a 1 and this is a 1?
Oh.
So 1 over 1 is just 1. If this had been a 2, it'd be 2 over 1, it'd be y equals 2. Okay? All right, so clearly there's no holes in the graph. So what do we have? What do we have here if there's no holes? What other type of type of discontinuity we have?
Well, vertical asymptotes are 6 and negative 1.
X equals 6, right?
Yeah, x equals 6 and x equals
Good. So we've got all of our asymptotes done. We check for holes. Next, we have intercepts. It's already factored, so it's easy. Kelly, what are the x-intercepts?
0 and -4.
0 and
-4.
-4. How about the y-intercept? How about the y-intercept?
Isn't it 0?
Good. By default, why?
Because
Good.
it's 0 times, it's the numerator 0.
The numerator is 0, so it's got to be 0. Unless the denominator was 0, then it'd be 0 for 0, which is indeterminate. But also, look, if the x-intercept is 0, 0, you have to have a y-intercept of 0, 0, always. Because 0, 0 is the same one. All right, we've got everything done. So see how quick that was? What was that, honestly? 45 seconds, maybe a minute to get all that information. Then you take about, another 30 seconds. You draw your graph, your sketch. Then you go to your table. But draw a sketch first. Is that clear? So I'm going to give you a graph. Draw the graph of what you have so far. Then pick the points afterward. Don't pick the points first, because you pick the points based on your sketch. So let's sketch this together. So we've got y equals 1 for the horizontal asymptote. That's going to go off the screen. That's here. And I can't really emphasize enough how much you need to know your equations of lines. If you switch them up and write y equals 1, and you put a vertical line, and you do x equals 1 accidentally, your graph's going to look, it's not going to make any sense. So you need to understand that you need to graph a line, whether it's diagonally, like a slant asymptote, or a horizontal asymptote, or a vertical asymptote. So when you learn about these lines earlier in the year, you're going to be using all of them now. So this is y equals 1. What else? My next asymptotes. Next.
Yeah, vertical lines and -1 and 6.
And now maybe I'll use increments now so we can see it. 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, and 1, 2, 3, 4, 1. All right, so over at 6, we're out here. Next. Niall, what's next? After we got the vertical asymptotes and the horizontal.
Yeah, intercepts.
Okay. So the origin is the easy one, right? Let's put the origin right here. And then the y-intercept is the other x-intercept is -4, comma 0, which is out here. It's going to be an odd-looking graph. Or probably... Okay, let's go with it. Everything looks clear to everybody else, right? Nothing's off? Yeah, looks right. Okay, so we got to pick points now. This is odd, right? Because I'm expecting it to be like something where we have like a piece here maybe, something up here, and then something down here. but it looks like this one's going to be a little bit odd looking. Anyhow, let's pick some points. So I would pick points in this region out here, pick some points in this region in here, and then maybe even some points out here. Not really sure what's going to happen, but we didn't get any intercepts out here because this one might be up here, right? Maybe this portion will be out here, which will explain why we didn't get any intercepts. Kelly, you have a weird look in your face.
No, the graph just looks like really weird.
But is it something like this though?
Yeah.
Okay, so let's choose points. This is going to be odd. So let's go ahead and choose x values. Let's pick, since our vertical asymptote is -1, let's pick -1.5, -2, -3. We have -4 already, so maybe just jump to -5. That'll cover this area out here. Then in here, we'll choose -0.5 to get a point out here. Then we'll go ahead and pick, let's say 1, or maybe even 2 and 4, because we don't need a ton of points in here. Let's pick 2 and 4. I'm going to move everything up, hold on. So I've got 2, which is right here. I'll choose 4 here. Then maybe I'll go to 5.5 to get close to the 6. Then on the other side of the 6, I'll choose 6.5 right away. And then I'll go to maybe 7 and 9 to change my increments up a little bit. So this is an odd looking graph. This is an example that just happens to have a lot of points we're going to need to utilize. So go ahead and type in the original function in your calculator. Type it into y1. Go to your table setting and just literally type these points down and start filling in your table. What was the original? Can somebody read it to me real quick because it's off my screen?
X squared plus 4x divided by x squared minus 5x minus 6.
Thank you. We called it h of x, I think, or something like that. So go ahead and type this in and make sure you put parentheses around the whole numerator and parentheses around the whole denominator. That was going to run about a minute. Okay, so I'd like to quickly go through this. So I'm going to give you these points. Anybody got the first 5 of them done? Kelly, go.
-1,
Go ahead.
-0.5,
Go ahead.
-1.7,
Keep going.
-1.2-ish,
Okay.
-0.5,
-0.5, right?
yeah,
Okay.
-1,
Okay, 4.
-3.2, and my calculator won't let me go.
Yeah, so go up, scroll up, and overtype it. Scroll up a few, and hit type in 5.5, 6.5, 7, 9. 5.5?
-16.08,
6.5?
18.2,
7?
then 9.65,
And 9?
3.9.
Okay, this makes sense. These points do make sense. Look at them. -1.5, -1 is right here. Oops. -2, comma -0.5 is right there. -3. Are we certain if -3 was -1.7 or -0.7 or no? Yeah. Okay. This decimal should be over here for sure because it's got to continue to move up. And then let's see, -5, we got back to -1. What was -5?
-5 was
0.11. And that makes more sense because this curve should look like that. Check these values. These ones look good down here at the bottom. Okay, these ones here are definitely right because this is why it's off the graph. It's going to be up here for sure. And then I'm guessing this other one is going to look something like, let's see. You can start packing up. That's fine, guys. This other one's going to look something like this. I'm guessing, just by the nature of the points. Okay? Make sure tonight you finish up any homework you owe me and submit them. Some of these still owe me for E3 or E4. Have a good day, guys.